When you set it up in the table, set it up in the
Alright.
Okay, there's only 2 bars at
Yeah.
So if you look, that little bitty piece is 2-1, the next piece on top of it is 3x, minus 24, the next piece is that. So you look at it as again, or, I'm seeing.
5x plus 4 is 1 minus 1
Oh, yes, sir, you're right. There you go. So now you don't have that. You can solve for x by saying divide x plus 4 equals 114, right?
So, what have you done? Stop.
No, put up the...
No,
No, that's your paper pen. And then divide by 5.
Yeah.
So you find out what x is. So you can solve the next single here with 3x. Solve for this side. There you go.
So 114 plus 42.
Are you gonna check these here in a minute?
Oh, we ain't gonna get a grade for these? Boom, Y is 12.
Well, you should write it down as you go.
415.
Yeah,
Go back and rewrite it and prove what you did.
No.
all from it.
Everybody. Yeah. So.
Shoot, we're already doing that, right? Oh, I thought you were talking about
Yeah.
The last one.
Huh?
Yeah.
You don't even have to take it.
Hey, if you got work to do,
I just finished.
I see this thing. Did not do this.
Did you say why you do that? But you want to
Yeah.
Yeah, I think
And like, yeah, I think it's hard to drive. I didn't do one when I was broken ankle. Hard
Give me one.
No, I've got all the answers. Let's go sit there. Yeah, we did it together.
Where's your paper?
Hey, what's the answer for that one?
I'm not giving them. You find it and you tell me. Do not lose your word. That's what's going on.
Oh, it's fine.
Well, are you certified to equal these tonight? Yeah, can we do two, let's go to people's back? It's all done.
You didn't number anything, boy. Wait, it's got a number stuff, so we know where you are.
I didn't know it until you started writing it.
Yeah.
Oh. Well, gotta get enough pepper out, boys.
I know you're working. You know, what did you do? This isn't as good.
These aren't was it open? Yeah.
Go back to your picture.
And then, okay. This is our straight line right there. So there's this piece right here that's missing the other line. Can't do that. So we're gonna do this. Oh, how you got that right? Without this one.
I got the answer for 22.
Oh, I already did 23.
Number 22 is in the book. Should have checked one.
Not day 23.
You got which one's in there?
Yeah.
What's that? Where's that class together?
Those are one.
Yes, but you have to be here to find why. That was the original thing. You have to take, you just like the this. You're solving for this one right here, the water. So you're going to have 114 plus this plus this. So you put the next one inside of it first, back to the 14. So then once you you're going to have 3 times 14 minus 24. And you may have to do that on the calculator with that. Okay, now solve for that. And that's where I get lost when you're at shoulder. When you do stuff in the company, you don't put down what you're doing. That's where I get lost when you figure out this. So that's where you got the 40. That's where you got the 40. And then this plus this plus the 2y will give you yourself the y equals 180. Because that's the square line right there. So you're going to be 1 more time, just 42. That's 2y. Equals 180. That's also y. That's how you did that. But I don't know how you did this. It came out right. It was an accident that it did, I guess. I don't know.
Because Molly's a goat.
Ma'am.
Uh-huh.
What are you doing together?
I'm not a good one to you, though. My foot's killing me. So bad. I'm going to cry myself to sleep.
Okay, so if you're not done with these yet, you can take them home and finish them. Here's what we're going to do today. We're going to get into the next section, and I need everybody in the next section. So turn to page 56. Turn to page 56, everybody. This is not a section that I'm actually going to give you work in. But there is a lot that we need to pull out of this section, and most of it is just recognizing and hopefully remembering. It presents to us some new symbolism, new vocabulary. There's just a lot. This is what you think geometry is about when you see that geometry is on your schedule. Oh boy. I get to draw shapes.
Really, I thought geometry was going to be harder than algebra, but algebra is harder than geometry.
Alright, here we go. On page 56, very first highlighted word is the word polygon. Polygon. It's a closed figure. And you've been working with polygons forever. There's some that are very familiar to you. A triangle, square, rectangle, parallelogram, polygon. This is a compound word. Poly means many, and gon means side. It's a shape made up of many sides. A polygon is a closed figure formed by a finite number. That means if it's supposed to be a four-sided shape, it will have four sides. However, there is not a limit on the number of sides that a shape can have. If you were able to, you could sit down and you could draw a polygon that had 1 million sides. Polygon. What's the fewest number of sides that you could have and still have a closed figure? 3. You have to have at least 3 in order for it to be a closed figure. So the smallest polygon in terms of sides, number of sides, would be a triangle. And then there's no limit on the largest. Once you get past normal counting numbers, we run out of names for the polygons and we just call it an n-gon. N-gon. Where the n stands for whatever number you want to put in for it. That's how many sides it has. N-gon. The corners of polygons, they are all vertexes. In this particular picture here on page 56, point M is a vertex, point L is a vertex, point K is a vertex, point J is a vertex. Anywhere there's a corner is called a vertex. Vertex, remember, is just a place where your graph changes directions. For point M, this line segment is coming down this way, and then at M, it turns and it goes that way. Till it gets to L, and then it turns and goes that way. But for our thinking, a vertex means a corner. There are many different shapes for polygons. These are examples of polygons. These are not examples of polygons. This one is not an enclosure. This one is not made with strictly line segments. This is 2 enclosures. This one is not made strictly with line segments. So polygons, not polygons. Concave, convex. Throughout the entire book, this is probably the only time that we're ever going to mention concave and convex. How do you enter a cave? Say that again.
Just walk in.
You walk in. If the shape somehow goes in, it's concave. If there's nothing about the shape that causes it to go in, it's convex. Going back to these examples, this triangle is convex. Right below it, the parallelogram, convex. This trapezoid right next to it, convex. This shape right above the trapezoid, concave. There's a part of it that goes in. Now what the book says is if you extend the sides to become lines, as long as all the lines stay on the perimeter or the outside of the shape, it's convex. But if there are lines that you can extend that cross through your shape, then it's concave. Next page. A polygon with n sides is an n-gon. An n-gon. Means it's waiting for you to plug a number in so that you can draw it, figure out how many sides it has. For example, a polygon with 15 sides is a 15-gon. In this table, it's kind of neat. The number of sides. Some of them are specially named like the triangle. There are 3 sides, it's called a triangle. 4 sides, it's called a quadrilateral. Stop, Sean. Get your head up. We're on page 57. Follow along in that book. Sean, put your head up. After the quadrilateral, they all end with the word gone. Gone. You're gone from those simple names, and now it's on to these. A 12-sided shape would be called a
Dodegon.
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 You're from Ector, aren't you?
Yeah. Identification.
That's dog.
That's not bad though, Skylar. Here's how you would say that. Gone. Dodecagon.
Decagon?
Dodecagon.
No, you just go with a K.
What?
You just go with a K. Or English done.
So try the 11-sided shape.
Decagon.
Pendecagon. And a 10-sided shape,
Decagon.
it's just simply decagon. This is not your grandma, although this is a nonagon. 7-sided heptagon. Heptagon. We don't have to remember these. After we get past this section in the book, we're never going to need to know what a nonagon is. Here's the real meat and bones of this section, this picture right here. This introduces a lot to us. This is called a regular pentagon.
Oh yeah, 5 sides.
It's a pentagon because there are 5 sides. The part that makes it regular is these marks right here, which means that all 5 sides have the same measure. Okay, here's the note that you need to make. Regular means all sides have the same measure.
It's highlighted yellow.
Means it has all.
All sides have the same measure. So can you give me an example of a regular rectangle?
Quadrilateral.
Equilateral right
No, because not all sides are equal.
There's no such thing as a quadrilateral. It'd be a square.
Thank you.
You're welcome.
I said that. I thought square and rectangle are different.
They are, but
No,
you can't have
no,
one irregular.
no. No. A square belongs to the rectangle family.
Yeah, we did that. Just like it's different. It's squares like on all sides on them all.
A square is a special rectangle. All squares are rectangles, but not all rectangles are squares. So regular means all the sides are the same. That also means that it's what's called equilateral. Equilateral means the measure of all the sides are congruent. So when we're talking about pentagons, the description isn't going to say you have an equilateral pentagon. It will say you have a regular pentagon. That's a big clue because you may only have some measure on one side. And you have to pick up on that clue, regular. Oh, all 5 sides have that measure. So I'm going to check your knowledge here. I have a regular triangle. One of the sides has a measure of 5. So what is the perimeter of that triangle?
15.
15. It's a regular triangle. That means that all 3 sides are the same. If one of them is 5, all 3 of them are 5. If a polygon is a regular polygon, it will have all sides the same And if all the sides are the same, then all the angles will also be the same. It will be what's called equiangular. Equiangular. Equilateral means all the sides are equal. Equiangular means all the angles are equal. That is exactly what's being shown to us by symbols in this picture. In the book, every time you see these little red marks here on a line segment, it means that it has the same measure as any other line segment in that picture that has the same number of marks. These marks are telling us that for this pentagon, all the sides have the same measure. The arcs in the vertexes are telling us that this angle has the same measure as all the other angles in this picture that have the same number of arcs. So this would be a regular pentagon because all the sides are marked the same and all the angles are marked the same. Would this be a regular polygon?
Yes.
No.
All sides are the same.
The angles aren't the same.
That's
The angles
correct.
look at the angles, Sean.
If it were a regular polygon,
Tony Dotson to the high school office to go home, please.
if it were a regular polygon, all sides would be the same and all angles would be the same. These two angles have one arc apiece in them. They have the same measure. But these two angles have two arcs. They have the same measure as each other, but not the same as the ones that have one arc. These two arcs are acute. These two are obtuse. And we don't even have anything to talk about these two angles. How about B? Is that regular?
Yes.
Right. It would be a regular what? What's the name of that shape?
Regular.
Octagon. There are 8 sides, so this is an octagon. It's a regular octagon. Would it be equiangular?
Yeah.
What does that mean?
All the angles.
All the angles are the same. Of course they are because they're all marked the same. It's equiangular and equilateral. Okay, let me see here.
They're not marked. Can it still be regular or equiangular?
It can. It will tell you in the description.
But it has to tell you.
If it doesn't tell you, you cannot assume that it is. There's more of the same through this section. Okay, that's really all that I want to get out of this section. Let me look at one more thing here. This is in the exercises on page 62. This rectangle right here,
What page is that, Mr. Mayor?
62. In this rectangle, all 4 angles are marked 90 degrees, so we know that they're all the same. All the angles are the same. However, on the sides, they use one mark on the top, one mark on the bottom to mean that they are the same. And then on the sides, on the left is 2 marks, and on the right is also 2 marks to mean that they are the same. If it were a 6-sided shape and we had all of a sudden another pair of sides that had equal lengths that were different, then we would use 3 marks on those. I know, good stuff, huh? If you didn't finish the assignment that was due today, get it back out, work on that.
What if we did?
Check it. Check it. Check your work.